Geometry, properties of rectangles, rhombi, and squares. So here are the definition. According to our textbook, HMH, um, the rectangle is a quadrilateral with four right angles. There are alternate definitions, and some of the books, instead of doing it that way, defines a rectangle as a parallelogram with a right triangle. I kind of like that slightly better, but can you show that these are equivalent statements? Well, if you sort of think about it, right? Let's draw a parallelogram. Oops. How about this way? Draw a parallelogram this way, right? And if there's one right angle, and we know that because the opposite angles are congruent, if this is a parallelogram, then this has to be 90 degrees. And we also know that the adjacent angles has to be complementary, right? If this is parallel, guys, like this, and we know that this angle and this angle right there are same side interior angles, right? So they have to be complementary, sorry, supplementary. So that, which means that if this is 90, this also has to be 90. Do you see that, guys? Yeah, so with this particular definition, right, it implies this definition, right? So they actually mean the same thing. Another way they could do this is call this x and x, right? Um, if this 90 degrees and the opposite side 90 degrees, right? So we know that 2x plus 180 is 360, dot, 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 solve for that x is 90. So we can show that these are 90 as well in that regard. That's using more of an algebra, okay? Okay, let's continue on, guys, okay? Uh, Proving the diagonals of the rectangles are congruent. All right, so that's what we're doing today. So given a quadrilateral is a rectangle, then it is a parallelogram. Hmm. So it's saying that rectangle is a parallelogram. It is okay, good. And if the parallelogram is rectangle, then diagonals are congruent. So they come in the same thing. So once again, we have a guided proof, and let's see if you could fill this out for me, guys. All right. All right, guys. Why don't you guys go ahead and stop the video and work on the problem. All right, guys, we're back, and here it is. So we know that the ABCD is rectangle, meaning we have four right angles, and then there also means that they're parallelogram. Okay, so our job is to show that they're parallelogram. Well, here it goes. We could separate this into triangle ABC, sorry, ADC, and BCD like this, right? And we know that the ABCD is a rectangle that's given. And then A and C are right angles, because that's the definition of rectangle, right? Right. And A and C are congruent because all right angles are congruent. And B and D are right angles. That's definition once again. And B and D are congruent, same as 3. You don't have to write it over again. If it's short to say same as 3, you could do that. And we know that the ABCD is parallelogram because if the opposite angles are equal or congruent, then it is a parallelogram. Now we're continuing on to show the second part. That is to say that the opposite sort of diagonals are congruent, right? Right. We know that the AD and CD, AD and CB are congruent earlier because if a quadrilateral is parallelogram, the opposite sides are congruent. And we know that the DC is equal to itself, right? So we know that the AD and this two things are congruent, and we know that these two are congruent, right? And they're both right angles, right? Right. And D and C are right angles. There you go. And they're congruent to each other. There you go. So these two triangles are congruent by side angle side. And by CPCTC, AC, sorry, let me just make that slightly smaller. AC therefore has to be the same as BC. There you go, guys. All right. Not too bad, is it? Okay. All right, so let's move on to the second phase of idea of this particular lesson. So we're talking about rhombus. Okay, rhombus by definition is a quadrilateral with 4 congruent sides. Okay, given that, we are supposed to figure out um, the following properties. If the quadrilateral is a rhombus, then it is a parallelogram. Okay, and if it's a if the parallelogram is rhombus, then the diagonals are perpendicular, and then the parallelogram is rhombus, then each diagonals bisect a pair of opposite angles. We're not going to do all the proofs over here, guys. Let's just do one of them to show that the diagonals are perpendicular. Okay. All right. So why don't I go ahead and just show you the answer for that one. Okay. So the way we would do that is the following. Okay. What do you know about JM and JK? JM and JK are congruent, right? So I could say that since JM is congruent to JK, right? And we know that LM is what congruent to LK, right? The points J and L are, can you anticipate what I'm going to say? Right. J and L are on the perpendicular bisector of MK. That's right. Because of that, therefore, we could say that the JL is perpendicular to MK. Not only that, it's a perpendicular bisector, right? So we know that they bisect these two. And you could make an argument going the other way, this way, and show the same thing. By doing so, you could show that the diagonals bisect each other, right? But I think if you show the first one, that's kind of obvious anyways, because the parallelograms, diagonals of the parallelogram bisect each other, right? How could you show the first one, right? One of the ways is that what? It says the 4 congruent sides, right? So this was pretty straightforward, right? If you got these four things are congruent, we know that the opposites are congruent, right? If the opposite pairs are congruent, then that implies that this is a parallelogram. All right, that's pretty straightforward, right? And then if the parallelogram is a rhombus, then each side bisect each other. And I can sort of help you with that a little bit. The way you would do that, guys, is to show that these two are the same, these two are the same, right? Isn't it? Okay. Oopsie. I don't know what just happened just now. Hold on. Okay, let me find my way back. There you go. Okay. All right. So one of the things you could do in this particular case right here is that these two triangles are congruent by side, 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 right? Because that's reflexive right there. That means that this angle and this angle is the same, and this angle and this angle is the same by CPCTC, and the diagonals bisected the opposite angle. And yeah, that's it. Okay. All right, let's continue on to do some examples with you guys. Okay. And at each point, you probably should pause the video to see if you could do this on your own, even if I don't do that, right? And if you could do it on your own, that it means that you have a good command of the current material. It might take a little bit longer, but I would highly recommend that you do that. Okay. And we know that the quadrilateral of VWXY is rhombus, is given to us. And how do I find XY? Well, we know that all the sides are congruent, right? So because of that, we know that the VW is equal to WX. And the VW from the given information is 6m minus 12. And WX is 4m plus 4. Solving for that, moving 4m to the other side gives you 2m. Moving the negative 12 to the other side gives you 16. So m must be 8. but we're looking for xy, right? But we know that the xy is equal to the opposite side, or in fact, it's equal to any other side. So let's go to VW in this case, right? It seems like a nice number. And that's 4 times m, which is 8, plus 4. And that gives you 36, right? So therefore, I could say xy is equal to 36. There you go, guys. All right. So now the question is, how do I find v, so y vw, y vw, this angle? Okay. I think that we know that for a fact that these two angles are equal to each other, right? So if I could find this angle, the YVW is twice that angle, isn't it? Right. So you should sort of think that through and maybe even write it down. The angle YVW is the twice the measure of the angle WVZ, which is twice the 9n plus 4, isn't it? Okay, now the question is, how do I find the rest? Is there anything that here will tell me how we can find n? Oh, look at this. This one is equal to this, but we know that it has to be perpendicular, right? Because the diagonals are perpendicular bisectors, right, of each other, like this. So we could say that we know that the 3n squared minus 0.75 is equal to 90 degrees, right? Because if I ask you for a reason, you have to be able to state it, because the diagonals of rhombus are perpendicular, right? Solving for that, add 0.75 to both sides. That's 90.75. Divided by 3, it's n squared is equal to 30.25. Using your calculator, it turns out the n is equal to 5.5, right? So this right here is 9 times 5.5 plus 4. And if I'm not mistaken, that is 45, 45, you double that, blah, 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 blah. Actually, you know what? I'm not actually doing it the way you do it. I'm actually distributing this to over here. So I'm going to show you what I'm thinking right now in Thought Cloud. So if I distribute this to over here, I just multiply it to the 5.5, which is 11, plus twice the 8. 4 is 8. So that's 99 plus 7, right? So that's what I'm thinking in my head. Okay. Anyways, yeah. So I don't know where I should put that. Okay, let me erase that. So I'm going to show you the part that you don't really have to show me, but if you do, that's fine, and that gives you 107. So if you feel comfortable doing this in your head, that's great. If you want to work it out, I would recommend that you write it out, but I'll trust you if you tell me that you can do that in your head, right? Doing mental math is a good idea, okay? But always follow through and double check, okay? All right, so this there's a point that I want to make, which is that according to our textbook HMH, a square is a quadrilateral with 4 sides congruent and 4 right angles. There's an alternate definition, obviously, and I prefer to think of it this way. I prefer the following alternate definition, which is to say, square is a quadrilateral that is both rectangle and a rhombus. Okay, and you can list all the properties of square. Okay, so you should probably think through that, and that'll probably show up in the next exercise. And here's your turn, guys. Do me a huge favor. Take a time and stop the video and work on them. All right, guys. I'm going to assume that you did spend time working on it, and here are the answers. For the first two, for the second two, second one, second group question is over here, and the last couple is right here, guys. All right. So I'll see you in the next video. Have a good night.